Greetings and welcome, friends. Mr. Waddy here. We are continuing our look at section 3.5, graphing linear equations using slope-intercept form. And today, I guess the goal, so to speak, is we're going to target verbal descriptions or word problems, things of that sort. And being able to try to decipher or discern that information, boil it down into a slope and a y-intercept, so that we can write the equation and graph the problem. Let's see. So let's take a gander at this problem here. It says a linear function g. Okay, all right. You can call it g. It didn't have to be an f of x. Could be a g. Models a relationship in which the dependent variable, dependent, I want to point that out. That means output. Okay, that would be y in some cases, right? Okay, which yeah, I guess we can use because they called it y there. Increases 3 units for every 1 unit, the independent variable. So that is the, actually it kind of lined up with x right there. That is the x value increases. So output increases 3 per 1 of the x. The rise is 3 over 1, okay, is kind of what I might think about that as. So I'm actually going to write that m is equal to 3, right, for every 1. 3 over 1 is my slope. Let's see, then it says graph g when g of 0 equals 3. So if I plug in 0, my output is 3. Plugging in 0 for x conveniently happens to be, right, that I could think of as 0, 3. That happens to be the y-intercept, b equals 3. All right, that looks kind of like a 6 there. I think I made it worse, but that's fine. So it says identify the slope, did it, the y-intercept, done, and the x-intercept of the graph. We'll graph this first to find the x-intercept, but you guys might recall that to find the x-intercept, you could plug in 0 for y if you want. We actually don't have the equation though, so maybe you wouldn't have. So let's see. Let me. I'll just make this my y-axis, something like that. Little scribble scrabble there. This looks like a good x-axis, somewhere about there. And let's plot our points. So my intercept, the y-intercept is at 3, like so. The slope was 3 over 1, or just 3. So if I go up 3 and over 1, that would be another point on the line. I'll also point out that 3 over 1 is the same as negative 3 over negative 1, right? So I could also go down 3 and backwards 1. That would also work out. Let's see. Can I making some lines all of the time. Here we go. And voila, there is my line with a slope of 3 and a y-intercept of 3. So you guys could actually, with this information, even though they didn't ask for it, we could have said y equals 3x plus 3 was the equation. And what is the x-intercept here by the looks of it? Where does it cross the x-axis? Well, positive x's are over here, negative ones are over there. Negative 1, yeah, so the x-intercept is negative 1. All right, so that was, just kind of reading the problem and figuring it out. Let's do this next problem, example 6 from your Big Ideas book, talking about submarines. Interessante, submarine. Okay, here we go. I'll make that a little bit bigger. That'll do, pig. All right. A submersible that is exploring the ocean floor begins to ascend. Clue. That sounds like a positive slope to me. I'm guessing. All right. Ascends to the surface. the elevation h in feet of the submersible is modeled by the function 6 h of t, the height at any given time, is equal to 650t minus 13,000, where t is the time in minutes. Okay, so since the submersible began to ascend, graph the function, identify its domain and range. Oh, wow. Oh my. So let's see. First of all, here's my equation. What is my slope? It's the number in front of the variable. So it's going to be 650. I could think about that as 650 over 1, which will help when I'm doing the part 2 there, part B. And what is the y-intercept? Yeah, negative 13,000. Yikes. I hope I'm not going to be counting by ones on my scale. Now, now it asks us about domain and range. Let's think about that for a minute. The domain are the possible x values, so that's the set of all x, such that, now if t is the time since it started to ascend, that means it wasn't deeper in the water before that time necessarily. Maybe it was like just traveling flat across and then started to ascend. So I don't know anything about t values before t equals 0. So I think actually we should even use the correct variable t then instead of x, my bad. So the domain will be the set of all t such that t is greater than or equal to 0, guessing. We might have to modify that a little bit later, but it has to be positive, right? I can't have negative time in this instance because it wasn't necessarily ascending prior to that. This pattern would not have continued in that direction. So I'm thinking that t is going to be greater than or equal to 0. But I also am expecting what happens once it reaches the surface. It can't keep ascending, right? Like submarines can't fly. No. So I'm going to write this as 0 is less than or equal to t is less than or equal to some yet to be determined time when it reaches the surface, because it can't keep just floating into the sky, into space forever. We don't have those kinds of submersibles yet. And then let's see, the range is the set of all h such that, so the height in feet, well, I know that can it be negative in this case? Well, it starts at a negative number. Yeah. And so the height, but it can't be bigger than 0. It's not going to be floating up above the water, really. And then I don't know the lowest that it goes. So right now, my range and domain, we've got some blanks that we've got to figure out. But I'm expecting that in terms of a quadrant that this exists in, since it's never going to be above the x-axis, it's never going to have a y value that is bigger than 0. I can just make my x-axis the top of the graph. And then my y-axis, I said that the time's never going to be negative, so I don't need to have x values that are negative. So my y-axis could be right here, because I don't care about negative x values or t values in this case, right? So here's my y-axis. Now, in terms of my x-axis, we'll have to see. But y-axis, let's label our y-axis as far as units. I need to go down at least as low as 13,000 negative, that is. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I could actually count by thousands for each of these. So I could have negative 1,000. Maybe I'll just label every few. Negative 3,000. This would have been 4,000, 5,000, negative 5,000. Right? 6,000, 7,000. I'm not going to label all of them, but but I could have counted by thousands. You also could have counted by 2000s, which is what the book decides to do for this problem. And then for the x-axis, I don't know how far out like it's going to go. I don't know how steep this is. But if I found out what the x-intercept was, that would be helpful to me to knowing kind of what should I count by. Oh boy. Well, the book decided to count by twos, by the looks of it. Yeah. So yeah, 2, 4, 6, 8, 10, 12, 14, be there, 16, 18, 20, 22, yeah, something like that. Which I could have figured out what is my x-intercept going to be, so I could have then figured out where it's going to go, because this has a positive slope because it's ascending. So let's plot our points here. So negative 13,000, this was 9,000, 10,000, 11,000, 12,000, 13,000 right there. Bam. That's as low as we go. And now it's increasing by 650 feet per minute. Okay, 650 feet per minute. That was what my slope was. So that means it's going to go up 650, which is not a full 1,000, and over 1, which is only half a block. Okay, and then up another 650, which is like a little over, yeah, a little more than, it'll go over that 12,000 foot depth, and then over another half a block. I don't know. This one's a little bit tricky. This is where graphing becomes a little less accurate. This next one would be underneath, and I could have picked some values and plugged them in. You know what? Maybe that x-intercept will be helpful to me if I do the intercepts method. You guys want to find the x-intercept? Because like I could land really anywhere here depending on which points I decide to go through, since my points are so sloppy. Let's find the x-intercept. I think I don't know of a better way to do this. So to find the x-intercept, what do? I plug in 0 for the output. So I'll have 0 equals 650 t minus 13,000. And to solve for t, I would add 13,000 to both sides. All right. So I'll have 13,000. Yeah, this is really the best way to do it for this problem. I don't know a better way. And then divide both sides by 650 to get t by itself. And let's see, I'm grabbing a calculator on this one, friends. 13,000 divided by the 650 happens to be an even number, like around an integer. Wow, I get t equals 20. That means it takes 20 minutes for it to ascend, and that means our y-intercept is right here at 20 minutes. Wow. So now let's draw that line. Yeah, so my points were actually pretty close, even though they were really roughly drawn because I didn't have those values. And by picking a point that's further away, I was able to actually have kind of a better accuracy. If I plot points that are really close to each other, like I don't, I'd have a bigger likelihood of error. But if I pick points that are far away from each other, it's less likely that I'd make a mistake when drawing that line. So here's my graph. Let's see if we can figure out what would have gone in these spots for the domain. What was the biggest the t value, the time value, ever gets? Well, it was right between those. It was at 20 minutes. After 20 minutes, it's not going to be ascending anymore. This line won't make any more sense. Like maybe it'll just flatten off, or maybe they're like, oh no, right, and they retreat. I don't know. Who knows? So yeah, t is less than or equal to 20. And then what was the smallest y value it had? Let's see, the biggest it got to was 0, which we'd already predicted. Yeah, these are negatives. So what's this lowest y value here? Yeah, negative 13,000, right? So that's kind of my domain and range. Now it says interpret the slope and the intercepts of the graph. Okay, so for part B, so the slope, what does that mean in terms of this problem? The slope was 650 over 1. That means the sub was rising 650 feet per 1 minute. Right? That's what that means. That's the steepness of the line was the rate at which it was rising. And that's one of the things that are going to help us for word problems is that slope is going to have this per concept in it. It's the rate. It's going to be the y unit change over the x unit change, right? We did a problem Friday where we had a miles per hour come out of a problem where we were comparing, right, distance and our time was our x-axis and y-axis was miles, right? So yeah, hours and miles. And so the rate is going to be our slope. So when you're writing equations and you're given facts in a word problem, your rate will be your slope if it's a linear situation. Let's see, what does the y-intercept represent? What does negative 13,000 feet, so 0 comma negative 13,000, what does that mean in terms of minutes and feet? Well, what does the time represent? It was the time since the submersible began to ascend. So when time is 0, what does that mean? So when, oh man, when the sub begins to ascend, how deep is it? It is 13,000 feet deep, right? Is what that means. And then how about the x-intercept? So that's like 20 comma 0. So what does that mean in terms of this problem? 20 was in minutes, 0 was in feet. What's happening to the sub at 20 comma 0? At 20 minutes in, it has fully ascended, right? It's at the surface of the water. Yeah, maybe it will say that. It has reached the surface. Right? If it's 0 feet under the water, it has reached the surface of the water. All right, so not only being able to write equations, but also then being able to interpret them from the graph and just kind of take these coordinates, take the slope, take the y-intercept. What does that mean in terms of the problem? Actually, before I leave this problem, what happens? What's going on at this point? Could someone tell me what's going on here? Let's say this is the point 10 comma, I don't know, it's probably negative 6,500, I'm guessing. What does that mean for this submarine? What is 10? It was time in minutes after it started ascending. So what's this mean? Well, it means 10 minutes after it started ascending. So 10 minutes in, yeah, the depth of the submarine is 6,500 feet. Right? So that's what that one point would represent. So trying to recognize that all of these points on the line represent different points in time, right? In time, and depths of this submarine. Okay, let's do one more example. This is a problem from see, where is this from? Yeah, I think this is from a Pearson-Holton track 5.3G. Yeah, so I think it's on the separate packet that I gave you already. So this is Pearson-Holton's Algebra 1 track 5.3G problem 35 is what this is from. But it's about my buddy Phil, actually. It's pretty crazy that Phil, they were looking for people to write into word problems, and they found my buddy Phil. They're like, we want to write a word problem about you and tell your story. And he's like, really, me? You think my life deserves a word problem? And they're like, yes. And so Phil now is just like famous. It's amazing. His life is completely different now that he's been in this word problem. I do know of a person named Phil. Hi, Phil, in case you're like, hey, he does know a Phil, but this isn't about me. No, I made that up. I'm sorry. But let's see. Let's take a look at this problem. When Phil started his new job, beginning of time, okay, he owed the company $65 for his uniforms. All right, so it sounds like he purchased uniforms. All right, that's probably a one-time cost, and he owes the company $65. It says he is earning $13 per hour. Per hour. That's a rate, friends. What did I say about rate? That's likely going to represent, if this is a linear situation, which it is, what does 13 represent? In terms of the equation of a line, is it the y-intercept, x-intercept, the slope? What do we think 13 is going to be? Going to end up being our slope. $13 per 1 hour. Okay, so $13 per 1 hour. The slope is going to be 13. It says the cost of his uniforms is withheld from his earnings. Write an equation that models the total money he has. M is the money. Okay, so I guess that's a little bit tricky because I used M for slope. M, the money he has, M, after H hours of work. What is the graph of the equation? So, all right. So he's got $65 in debt when he started his new job. So what does that mean? That means hours was equal to 0, and that he owed the company. That sounds like he's in debt. That's negative, and he owed them $65. So I'm thinking that the y-intercept, where we begin, where Phil starts, is going to be 65. Except they didn't say that wasn't like a $65 signing bonus. That was like a $65, you owe us $65. So negative $65, that was a terrible dollar sign, is where he starts as his y-intercept. So if I want to write the equation in terms of M and H, I will say his money is equal to 13 times H minus 65. So here's our equation. So let's draw the graph. Let's see. So he starts a little bit negative. I've got to figure out what my y's are going to be counting. It's going up by 13s. So I should go at least as low as negative 65. Maybe I count by 20s? Maybe. So let's see. So I'll need my x-axis to be right about here. So this would be like negative 10, negative 20. No, sorry. I was counting by 20s. Negative 20, negative 40, negative 60, and negative 80. So that way I'll have space to start at negative 65. The slope is positive, so it's going up, right? And let's see, let's label some of those points. I'll just label this 40. I'll label every other 80, 100. No, I did that wrong, guys. That would have been 120. And then 100, 160 and 180. Nope, guys. Good thing I got my undo button. Yeah, yikes. All right, and now I've got to figure out hours. How many hours of work Well, I don't know. People work like full-time jobs, 40 hours in a week. So maybe I should count by fours for this. What do you guys think? I don't know. I think this is 10 across, roughly. 1, 2, 3, 4, 5, 6, 7. No, it's like 16 across. Yeah, let's just count by fours. So that would be 4, 8, 12, 16, 20, 24, 28, 32. Hopefully it doesn't take them a full week's work to get out of debt with the company. 36 and 40, right? I probably should have only just labeled every other, but there we go. So let's plot our point. It's at negative 65, so that's not halfway between 60 and 80. It's actually a quarter of the way, something like that. So there's our y-intercept. It might not be a bad idea. I think we should find our x-intercept because plotting these points, moving by the slope, going up 13 over 1, yeah, like I'm working on such a small scale here. Let's find our x-intercept. All right, that means I would plug in 0 for dollars. When does he break even? 13h minus 65. Let's solve real quick. We are such good solvers these days, right? Expert solvers. How many hours? It's not going to go in evenly, I don't think. And so I will get the h, those hours. Let's see, 65 divided by 13. Oh, what? No, they didn't. It did go in evenly. 5 hours. All right, so maybe I shouldn't have been counting by fours. Oh, well. Such is life. So let's see, 5 hours in, he'll be at 0. So a quarter of the way between the 4 and the 8. And let's draw our line. Yeah, that's what it's tough to know exactly what your graph is going to look like in advance. Let's see, I can't land that point there, so I'll just have to have it pass through it, something like that. Yeah, it's hard to know the window of your graph before you graph it, right? But at least we got some interesting information here. Actually, we can't go past that. But assuming this, it does go forever, and he just earns all the money with all the time in the world. So let's see. What is the graph of the equation? We got it. Write an equation that models the money. We got it. Let's actually analyze some of this data. All right. What happens here? What does that point appear to be? Yeah, so 12. It looks like it's halfway between 80 and 100. Because I got to remember my scale. Thinking it's somewhere like that. It's not going to be exact, I know, but what would that mean in terms of Phil's life? What does that M and H mean, or that H and M rather? This is hours. This is monies. What does 12, 90 mean for Phil? Not necessarily, not quite. For every 1 hour he's getting $13, but it means 12 hours after he started his job, he's in the green or the black, I guess, $90. All right, so because he finally got out of debt. What did this point represent? What did the x-intercept mean? That was when he finally paid back the company, when he broke even and had 0 money again. How many hours did he work? Here, for the x-intercept, that was the point 5, 0. That means after 5 hours of work, he finally had 0 money, right? So that was rough. He had to buy uniforms. Let's see. What if I asked the question, when will he have $200? How many hours of work does he need for $200? So to answer that question, I would read it across from here. That's where it hits. And now it looks like Phil will have $200 at about what time? Yeah, so he has $200 after 20 hours of work. Okay, so that's how we can kind of read the graph. We can interpret it. The steepness of the graph represents his pay per hour, right? That's his wage. The dollars per hour is the slope. The x coordinates represented the number of hours after he started his job, the number of hours of work he did, and the y-axis represented the money he had at any given point, which I want to point out that there did exist a point that he had like worked 2 hours and still was negative $40, right? These are rough estimates because my graph is so small. All right, but that's what those points represent. So the x-intercept was the break-even point when he finally had zero money again. That's kind of how we figured it out. All right, well, thanks for watching, internet friends. Have a good day. And go get a job, maybe. Maybe Phil motivated you to go make some bank. Bye-bye.